Hello, welcome to stream number 89 in this series where I'm streaming NES programming on a game live on Twitch from scratch. Let's pick up where we left off, which was, well, actually a little bit different than where I intended to go, but where we left off, I covered real briefly on Thursday of last week. We had that bug related to enemy spawning when we were trying to get some of the real art loaded that Jordan had sent over, and that is working. And there was a bug about the there was a bug related to the overflow of the address of the enemy information. So that got all fixed. And then after speaking with Jordan about how he wanted to create the artwork for the game and some of our ideas about how the game was going to work, we decided that we wanted to change from 32 by 32 metatiles to 16 by 16. I'd started doing some of that work here in the asset tool off stream, since I spend a lot of time on the asset tool, and not exactly the most exciting thing for some people who are looking more for the NES and 6502 stuff. So, but I unfortunately hit a slight problem with the change that I wanted to make for it to support 16 by 16. So let's get that looked at here. So let me open up a sprite. Let's convert this water PNG to a 16 by 16. Actually, I don't want to do that. I just want to change the canvas size. It'll truncate it, which is fine. Save. All right, so it's 16 by 16, and what I was seeing was that it seemed like the load of the file was fine from Tiger, but then the export as the metatile was not. So that part was no problem, and then I load this up. I was getting an issue with the rendering of the metatile. Where is... Huh. Why didn't that open up? NES asset tool, water dot metatile. Okay. So that's obviously not right. Similar problem to the other day. Oops. All right, so that didn't even load it. All right, let's see what's going on. Couple things. Let's first make sure that nothing obvious is wrong. So what we can do is let's do a little test here just to make sure that this isn't having some sort of problem. So I'm just going to blit the image on this test window. Oh, that was weird. Test window, tiger, current image. Okay, so I don't know why I'm having such a hard time with this today. Destination source, let's just do it at 202000, and then let's do test, no, current image width, current image height. Okay. And then what does that take? Oh, that takes the okay. So let's see. Oh, I gotta change the arguments too. What is the complaint here? All right, there's the flags argument. I forgot. Okay, so why am I not seeing anything? Why does it appear that nothing is actually running here? Don't care about those breakpoints. What just happened? It's not getting into this. Why? PNG to metatile, that PNG. Okay, so the image, we have our test window. Okay. Oh. Yep, that'll do it. All right, so there is the image. All right, so let's see what's going on. So I'd made this change to the metatile max dimension to be 16 instead of 32, which is what we had before. So that's all good. That is strange that it's not. So that can go away. We know that it's loading the PNG okay. And then we're going to the image palette. We can even do that. We can wait to do that over here because we can check the dimensions of the image first and then we go through here. So let's take a look at that and see, just step through what's going on. All right, so the color count. 1. Current palette. Is that doesn't make any sense. Why is that? Is it the converting it to indexed is broken? That's what it would seem like. So there was what looked like a bug here that maybe I fixed incorrectly, but let's see, if new indexed I, transparent index. Okay, yeah, so that was not correct. So this should be image indexed I. So we should be checking the original image to see if it was indexed, and if not, then we continue. Otherwise, we force it to a specific color. So indexed has a value in it. All right, so that may have been part of the issue. Close this. So we step out and all right, so let's look and see color count. Okay, 3, so that's better. Let's see if that makes it load properly now. Oh, okay, that was all that was wrong? Cool. So that looks good. And it fixed the grid, so now we can make the same thing as before. They're collidable, but only 2 by 2. All right, so similarly, we should adjust all of these other images. And then we need to go modify all the tile sets and stuff like that, and rebuild the map. So let's see, which we were using the water, and then we were using green tile, which obviously is not a problem to modify because it's literally just a solid green tile. So let's change the canvas size of that one. Oops, 16. Okay, we'll save that. And then PNG to metatile. Oops. PNG, green tile, dot PNG. Okay. And then should be able to just load that. Okay, cool. So that loaded. I don't know why that thinks it has a collision there. All right, so now the next one is, oh, is it because it didn't overwrite? I wonder if that's the problem I'm facing here, is that it's not overwriting the old file. Does not exist. That was another thing I added. I added some file existence checks because that wasn't happening. All right, so where is it creating that file if it's successfully creating the file? Is it creating it in curious. Let's see where. Save metatile. So let's look at what it's doing over there. Project asset PNG water. Oh, that's for the water metatile. So, I mean that's okay. Maybe let me put a little bit of output. Just to to help us there. All right, so and that's failing. Is that failing because the image is RGB? And that's indexed? That could be. That would make sense. Okay, so that was why. I suppose it should technically work with RGB, but for now I'm not going to mess with this. I can put a fix in there for it to check that, and we'll just have that in the next stream. But it should be checking whatever the expected format is. It should be checking for that and not assuming. All right, there we go. So that's got our green tile, and then we have the bumper file, which is just our collidable sort of generic. The nice thing is we've been working a lot on having some discussions related to the core gameplay Jordan and I have, and it's gonna, we've got a better sense of how we want the game to look. So, I mean, there's still a lot of work to be done on my side to make changes and start implementing some core mechanics, but that will assist him in building some more artwork for the game, which is going to be good. It'll be good to have all this programmer art out of the way. So there's that, and we can toggle the grid, and we say these two are collidable, save. All right, good. So those are the tiles that we've been using, and then if we go to tiled, essentially what we're probably going to have to do is just build a new map instead of tiles, tile sets, and then resave over everything. So let's do that. The tile sizes are going to be 16 by 16. I guess we want to do double the width then. Excuse me. We'll do 16 tiles by 200, just so it's an equivalent size. Oh yeah, we want to do that anyway so that it actually fits the screen on the width side. As far as the length of 100 tiles, I mean, we'll see what that actually looks like when we start implementing or going into this with the game code. If we're going to run out of space because of the size of the map now. Green tile. And then another new tile set, which we call water. Browse. Save. And then one last one called bumper. Save. Bumper. Yes. Okay. So now let's export this as JSON. This is bumper JSON. And the thing with this is once we get this established, obviously the goal would be that we wouldn't have to keep re-exporting this, right? Like the basic properties of these tile sets wouldn't change so much as the just the images would. Okay, so that's that. And then we want to add the external tile sets, which are green tile, water, and bumper. Open. All right, so now we've got our 16 by 16s, and let's start by flood filling the whole level with water. Part of the reason that we wanted to switch to the 16 by 16 is it gives you finer grained control over the way that everything looks, obviously. Gives you some better ability to leverage the palettes, again, more granularly, and work in some more fine detail. This doesn't even have to, I just want to have a pattern that's discernible. Those of you who have watched from the early streams will recognize this idea, where I'm just basically right now attempting to define a pattern that's visually recognizable so that we know that it was imported correctly. It's the easiest way I've found to confirming that what we're bringing in looks good. Anyway, so yeah, so this will allow us to make the graphics a little bit more detailed, and give us some more fun things we can do that we would be harder to do with a 32 by 32 metatile, which I had started with purely because it matched up to the attributes more evenly, but also that had less, that became less useful. Here, we'll make these kind of barriers you have to dodge. That became less useful when we switched over to the way that we were scrolling and updating, which ended up having to do half updates because we got rid of the what's it called? The status bar at the bottom of the screen, which that created in and of itself some headaches, but at this point it's it'll be okay. We'll get through making these changes in the assembler code. So let's see, so map, load world. I want to import the tile sets for the enemies now. So we'll just add this guy and maybe the scout ship too. So here's the medium ship. Put I had a problem with this last time. I couldn't remember how to do it. Layer. It's new layer. Eventually I'll actually remember how to do this. Insert tile, insert polygon, select objects. Yeah. That's what that is. That's an object layer. right. Sorry, like I said, I always forget how to do this part. No, not that way. Let's select object, but that doesn't help me. I want to place the object and can't for the life of me remember how to do that. I thought it was... Views, objects, blah, blah, blah. No, that's the object types editor, which I don't care about. That moves stuff around. Terrain stamp, terrain, wang, bucket, shape, eraser, rectangular, magic wand. Select objects. Yeah, I'm not expecting to be able to actually get through that, but we'll see. It's deliberately difficult to dodge there. Why am I having such a brain fart right now? I'm on the layer, looking at the objects. I've got the thing selected. Got an object layer. Select the objects. With this, you just select and click when you're on the layer that you want, right? So should be just the same thing, right? Or am I going crazy here? I don't see the enemies being added to the layer. It's not locked. I have the tile set. New tile set, embed, export, edit. That's fine. I always feel like an idiot when I'm dealing with this and I can't remember how to add the damn thing. Oh, okay. That's why. All right, let's bring that back on. So did that get added to the objects? It did. Okay. Sorry, that was frustrating and needlessly long. All right, let's get these guys added in. Really don't want you to get past that. All right, so let's export this map now to this. Okay, so we have all that. Let's now take a look at the export process. because it is going to load the file up and export the metatiles. Alright, so here's the first problem. This should be using metatile max dimension instead of being hard-coded to 32 by 32. That's just our filler first metatile, essentially. And then, let's see here. I'm just looking at how we're doing our export process for the metatiles themselves. And I think this is going to be okay in terms of it exporting correctly. Oops. Let's take a look at this and make sure that it's not doing the same thing where it's hard coding the dimensions of the metatiles. I don't think it is. I don't think it actually cares about that in the way that it's reading. So that looks okay. Let's go back to export. So we load the map and the map metitile to file system item. And then we export our palettes, and then we export our enemy objects, and then we deal with the metatiles here. And then we write out our includes and character ROMs. Okay, what is this? Empty metatiles. 16. Write out the empty metatile for metatile 0, and also write the empty collision bytes. Alright, so this is not right because it was 16. Oh no, wait a minute. Is that just mislabeled? No, because let me think about that. So every tile is 2 every tile is 64 pixels, and every pixel is 2 bits, so every tile is 4 bytes, right? Because that's 32 bits. Or no, wait, did I go the wrong way about that? Hold on a second. There's 64 pixels, each one is 2 bits. Oh, right, so that's 128 bits. Which divided by 8 is that 16? Alright, so that's just the one tile, 16 bytes. And then we're just writing out the individual individual tiles. It looks like it. That has no collision. Let me think about this here. So the collision map was a 4x4, which was 16 bits. So it was 2 bytes, and then we changed over to a 2x2, 2 tiles by 2 tiles, which gets us just 4 collision. So we don't actually need 2 bytes anymore for the collisions. We just need 1. So we're gonna have to resave those out. Let's see. This can just be a uint8. First, what is it? Most significant bits are, well, is it better to use most significant bits or least significant bits? I guess it's probably better to use the least ones because we don't have to shift out a whole bunch to start off with. So let's say least significant bits are collision for 4x4 grid, or actually 2x2 grid, sorry. Okay, which means that let's see, so we're drawing the grid for collision. Where is this? So we're going to change this. So if the metatile is selected, then we're shifting the offset of the selection and then putting it into this collision byte. So before we were shifting y by 16, or sorry, by 4, and then, or multiplying by 4, shifting it by 2, and then adding the x. So now we just need to do 1 shift. That should be sufficient. This is dividing by 128. The scale factor is still the same, so it's this 16 by 16 scaled by 16, which means we should get the same. Well, no, actually it doesn't mean we should get the same. We can get 16 times 16, which is 256. Oh, but okay, but the result is the same. Dividing by 128, we get a value from 0 to 2 because the image is less wide. So that's fine now. We just have to change that shift here because it was a problem. That's for sprites. All right, so that, let's rebuild that. Let's open up the bumper one because that's the one that actually has collisions. So if I toggle this grid and save that and then reload it. Okay, so the collisions come back there. Now let me just make sure that I did that right with the least significant bits, not the most significant bits. So if y is 0, it gets 0 shifted by 1, which is 0. Yes, I did. Okay, so that's good. And then we've got to re-export these other. And then, you know, we'll look at them just to make sure that they look okay. And they do. Okay, so that's fine now. Now we export and see how badly this is broken in the assembly. So we did have this problem that it didn't seem to export right unless I ran it from here. So I don't want to fix that right now. It obviously needs to be fixed eventually, but let's fix this. We'll fix that. I'll fix that another time. Shooter assets, shooter.text. Let me see here. Yep. need that set up there anymore. Okay. Don't need that either. Let's see, go into export, and I'm going to delete all of that stuff there. Alright, so let's run this and see what we actually get from the export process. And we got nothing. Export projects, shooter, assets, shooter.txt. Did I, shooter, okay. Well, let's see. All right, let's see what it doesn't like. So let's see if we get to, let's see if we get to here. No, we don't. Why? So load map. So we're reading our JavaScript file, and we're getting all the code for that. Oh. Why is it compressed? That's not supposed to happen. Or I didn't want it to happen. I guess it maybe is supposed to, but... Alright, so it zlib compressed the map, which is why it didn't load properly. What caused it to jump out, though? Should probably put something. You know what? Let's do a couple things. Let's have it get. Let's see. Type. Gets the type. The type is map. And then we go into here. Let's do this. Let's check to see if index JS code tokens, num tokens. Let's check to see if it's compressed. If we get a actually get a token back here. The map is compressed. Please save. Please re-export without compression turned on. And then exit with. Come on, autocomplete, really? Exit with error. I don't know why it's not finding that. Now bear in mind, this is not compression for the game. This is compression for the map file here on the PC. So obviously a lot less critical. We might end up actually wanting compression in the game, but that's not necessary right now. Here we go. CSV. That's why. Okay. So saved, and then let's re-export that. Because we don't really care how big this is for the purposes of converting. It's much easier to have it be a CSV than for it to be a, there we go, to be a compressed file. So let's do two things. Let's hit this breakpoint here, make sure that I remembered how this code works properly so that it doesn't incorrectly exit out. What? Didn't hit that breakpoint. Or it did, and I missed it. How did it get to this but not hit this breakpoint? Why is it acting goofy? So there's the JSON file. What's going on? This was just loading. Okay. Need more tokens. Okay. Did it actually print that? You know what we should do? We should say, do an assert. False. I think you can put a message in there. More parsing tokens are required. Okay, so now we should get a breakpoint. Why it's taking it so long to pull that stuff from Microsoft, but okay. Retry to debug. There's our assert. Okay. Because I'd rather do that while we're testing here than just print the message. Actually, we can do both because the assert won't do anything, I don't think, in release, so I'm pretty sure it won't. Error, need more parsing tokens to load map. Okay, so really? Okay. Give it 4K of tokens. It's a lot of tokens. All right, good. So that bypassed that. Now, just as a check, if I go back to tile, then I turn the compression back on, because let's say I wasn't paying attention, and I created a new map, and I export it. Let's make sure that that catches that and hits the error condition there. And it doesn't. Does get property index not work the way I thought it did? Returns 0 if it finds it, otherwise it returns -3, which is fine because it should just return non-zero. Compression. look at this. I'm looking at the wrong part of... Oh, maybe I'm looking at the wrong part. Yeah, I'm looking at the wrong part of the document, which would be... So let's see. So that finds the token index for the tile sets. Get property value. Okay, so I still have to get the index for type. Tokens, num tokens, type. You know what? It wouldn't get this far, so we don't even have to check that here in this case. All we need to do now is use the token index. Right, because what we're doing is in this JSON file, we're trying to look and see if... I want to do that for layers. That's within... Crap, okay. No, I'm just looking in the wrong spot. That's really what it comes down to. So, alright, sorry for that brief detour down the wrong direction. Let's go to where we actually look at the layers, which is here. And then, once we get to the layers, we have our token index. We check to see it's an array. If it is, then we go through our layers. And if it is the type tile layer, which is what we want, okay, cool. So then what we do is we want to do this check here. With token sub index, and the reason we're using token sub index is because we're starting from the token index because that's where the tile layer is and the whole list of tokens that it parsed. So yeah, so okay, this should fix the problem and have it error out if it's compressed. Let's see. Map is compressed. Please re-export without compression turned on. Okay, so it is calling that now. We just didn't see it because what was that? That was weird. Because it closed too quickly, or it didn't even close too quickly. It was in that output window from Visual Studio, which is tiny and appears behind the application for some reason. So anyway, all right, so that fixed that. So we hopefully won't have that problem again. We'll just get that error and we'll fix it and we're good. All right, so let's re-output this. All right, cool. So let's rerun the export process with that fixed, and hopefully that will generate properly. Okay, so that ran, and let's look at the export process output here. Good, and we got a bunch of stuff. And let's dump it into the working directory. All right, so now the fun begins, because now we've got to see how we make the actual assembly code do this. And okay, and we've overflowed by 782 bytes, which I thought might happen because we've greatly expanded the size of the map. So Let's do this. Can we change? These are the map properties. Can I remove or resize the map? Resize map. Okay, so which way is it resizing it? From the bottom or from the top? Or just... Or is it just like reflowing everything? Let's go back to 100. Let's see what that did. Okay, so that just truncated everything out of the map. Let's see. So let's offset 100. Can I do that? Can I? Oh, no. Apparently not. All right, let's... Oops, I went too far. All right, let's just resize it. I can drop stuff back in. That's not... Now that I remember how to do it, it's not such a big deal. All right, so let's use our green tile. We'll do our patterns again. Again, this is purely just to validate the loading code. Let's do that. Here, we'll give another little spot there. Okay, and then go to the objects, and we go to medium, and click on that, and then where is it? There we go. So have two ships there, and have those ships there, and save, and export, and do that, and save, place. Right, so that changed that, and let's re-export. Okay. I didn't realize I have this open still. Let me close down some unnecessary things. OBS is complaining about too many things being open. All right, and there we go. Now it stopped complaining. Go back to Visual Studio and re-export. All right, let's go to here, grab our export content. Hopefully we didn't overflow. Okay. And I mean, obviously this is going to be very broken, but let's just see where we're at and how this behaves. Okay, totally Totally broken. It's okay. That's more or less what I expected. So let's figure out what we're going to do here. All right, so let's start from the beginning. When we're loading the level, the basic premise of what we're doing is fine. It's when we start dealing with the actual content that things are going to be incorrect. So let's validate a few things. Let's validate, for example, that we get 100 loaded up in the debugger. All right, so load level. So let's make sure that we are getting a valid row count in A here. Which we should, that should still be okay. Except it says 64. Well, the height is 100. Oh, is it 64 hex? It is 64 hex. Okay, so that's correct. That's what I thought initially, and then I was like, wait a minute, is that just me wishful thinking that actually worked? All right, so here's the first problem, right? We're multiplying by 32 to calculate the maximum Y position, and that has to change to 16 because we're no longer dealing with a 32 by 32 metatile, so our height it will change as well. So let's do that. Let's go to there are too many files. I'm going to have to start moving some of the asset files into separate directories just to make it a little bit easier to parse through visually. All right, so we are doing this 5 times, right? 1, 2, 3, 4, 5 to multiply by 32. We no longer have to do that. We can get by doing this just 4 times for 16. And again, we're doing the ASL and the roll because we're shifting A, and then we are rotating the camera Y position by 1 to the left and shifting the carry bit on, which will get set depending on what the value of A is. The most significant bit will get shifted into carry, and then when we rotate, that bit will get carried over into the least significant bit of Y position plus 1, which is what we want. And then we're going to store this. Okay. Now, subtract 7 rows of 32, which is 224. That's no longer correct. We want 7. We still want the same amount. So actually, maybe that's okay, because it's just a pixel amount. 7 rows. Yeah, so this is just a note. It's really now 14 rows of 16. Right? Did I do that right? 224. 224 divided by 16 is 14. Okay, so that just doubled the number of rows, but that's okay because that's what we wanted to have happen. All right, so take the max rows, subtract 7, which is no longer correct. It should be subtract 14, which is E, right? Because we have double the number of rows now. Multiply by 8 to get the top first screen. Do a 16-bit shift using carry to move most significant bit to temp 2. So right now what we're doing is we are taking... Why are we doing it this way? All right, so we're taking our max row value, which is 100, and we're subtracting 14 to get the top location, and then we're okay. And then add the ROM address to temp2 to seek into the map accordingly. Are we... Let me think about this for a second. Arithmetic shift left, store into temp. Rotate left, temp 2. We don't actually have to do the store every time, I don't think, because we're not loading anything else into A. So just like earlier, we can say just ASL roll ASL roll load A, ASL roll, and then once we're done, we want to store A into temp. Add the ROM address to temp and temp2. But why are we... Okay, we're multiplying by 8 because that's the number of pixels. Okay. And then we're adding the ROM address and we're storing it into these locations. Let's see. If modifying the map, this is to change add 13 bytes minus 4 bytes for the palette indices. This all doesn't change because this is just related to the header information for the map. We didn't change that. So now what we need to do is we are loading in. So we're loading the address 2000 into 2006 to set up the name tables, right? All right, so then counts the number of tiles along the row, number on the column, 0 to 3. So this should now just become 0 to 1 because we no longer need to go that high. And if I remember correctly, all right, so this is divide by 2 to get our offset, so we just do 1 shift. Divide by 2 to get our shift again, and then multiply by row width. That's fine. Get the normalized metatile value, get the actual metatile value. So this is multiplying 2, 4, 6, 8. Find the subtile in the metatile. This is multiplying by 4. This should be multiplying by 2 now because it's a 2 by 2. All right, and then add in the row offset, and then load A with the value and write it to the name table. All right, and that's 32 that we're checking, and then done with one screen. So one screen, what is this? 1E is 30, which is correct. This should be ANDed by 2 now. Or wait, this should be ANDed by 1. And this should be ANDed by 1. And that's our essentially our modulo, where if we go from 0 to 1 and we AND it, the next value would have been 2, right? But because we're ANDing by 1, we go back to 0, which is what we want because of the way that the metatiles are now set up as being 2 instead of 4. Alright, so that is okay. Let's see if this loads properly, even if the attributes are messed up. Did it not reload the source? Or is that comment still wrong? Oh, multiply by 16. Where am I at here? Let's just rebuild this so that the... No, it's not technically that important, but it is important that we're actually getting the latest code. What happened? Load level. Oh, okay, I just ran it too far. All right, let's so we got our value, and then we're storing it in the camera. It's our palette stuff. Then we're doing our lookup. All right, let's see what that looks like here. All right, that's still pretty broken. Let's take a look at the PPU. Let's take a look at our character data. So we do have, that looks right. That's the bumper. That's our green tile, and that's our water tile. So that's all, it's all okay. No, that's okay. Let's see what the name table looks like after the initial start of the game. After we actually load up. I mean, so I knew this was going to be a pretty big change because obviously we're changing all the way the math works with the how we're loading up our tiles. But the question is, how big of a problem is this now at this point? So where we're actually storing the tile data is here, and then let's do this. I want to see what it looks like when we're done with one. So it loaded a bunch of tiles there. That's the attribute buffer. What is it doing? Oh, right. The attribute buffer is what we're using to store a copy of our attribute memory so we can manipulate it while we're running. what is it storing this into? Screen mem 23C0. So that's the next place that we're supposed to write to. Row mem is where the next bit of row data is. So it does not appear to have loaded this correctly, but it's hard to tell 100% because the palettes maybe, no, palette looks okay. That looks like that got loaded okay, so we're still just wrong in the way we're loading up our tile data. So let's go back and look at that. Let's look at what the actual tile data is and see if we're even close. My guess is that we've you know, hit a pretty major issue with it. So let's see what we've got. So I don't care about the camera stuff right now necessarily. All right, so tile X is going to be 0. Here, let's put these into here because these are the ones we need to look at. Tile X. Tile Y. Helps to type it correctly. So tile X is our actual X tile position, tile Y is our actual Y tile position, and then these are the positions within the metatiles, right? So we're going to load that into A. We're going to do a shift by 2. That's going to tell us where we are. So we're at 0. We're going to store that. Let's put that into temp here. Okay, and then we're going to load tile Y. We're going to do that same shift. And then we are turning that into, let's see, take Y and divide by 2. So we're getting the pixel location. Multiply by, oh, row width. No, wait a minute. Let me go back to source tree for a second. I want to So no, I haven't considered moving them into their own tasks. I mean, they're essentially the one and the same thing. I mean, the map loading, there's very little that actually has to happen. And then the drawing is part of going through the map data to actually put it into the name table. It's not really necessarily even two different things. So let's take a look. I updated this comment, but now I'm realizing that maybe I misunderstood my own thought there with the take max rows and subtract 7 and then multiply by 8. Okay, no, that's a different part of the code. Row width is take the Y and divide it by 4, multiply by 8, which is the row width. Oh, because that's the number of raw tiles. Okay, that's fine. All right. All right, let's go back to the debugger here. And then, right, because whatever the y value is in real terms, we want to convert it over from pixels over to the offset by y into the, okay. So clear carry, and then temp is the offset, which is 0. Transfer that to y. Get the normalized metatile value. So the sprite mem refers to the metatile we're trying to load. Let's go look at the map for a second here and look at what. So it's saying that's 3, but they're reorganized according to reorganized according to the value at sprite mem. So let's open up the memory and go to sprite mem. Sprite mem is, what did that say? 6E. And that gives us F78A. F78A, so that gives us our lookup. Except that looks wrong. F78A, not 8. No, I did that. Is it 8A F7? A. Why is this not? No, don't search for it. Go to it. 8AF7. No, that's not right either. So sprite mem. Yeah, F7 8A. So why is that saying 1? Y is 0. Load a metatile lookup X. Oh, I see. So that's, but they shouldn't all be 1. Something seems wrong about that. So sprite mem, how are you getting calculated? 13 bytes minus 4 bytes for the palette indices. We skip the row value earlier, and 5 bytes for the metatile lookup, and 4 for the sprite palettes. I mean, that shouldn't have to change, because it didn't change anything but the header. Is it? No, that wouldn't have mattered. Let's see, load a sprite mem, clear carry, add temp. Oh, it's possible that this code that I changed that I thought would work, maybe that's no good. Let's take a look at this again. So ASL, so I removed one of those, and then I removed this store. Because, what did I say? I said, okay, I have the max rows, I set the carry, I subtract 7 from it. And then I do a shift left and a rotate left, which is what I was doing here. I guess well, it shouldn't matter. So subtract, take max rows and subtract 7, multiplied by 8. max rows and subtract 14 multiplied by 8 number of pixels to get top first screen. Oh, that's not number of pixels. That was the number of metatiles before, wasn't it? 256 divided by 32. Yeah, so 256 divided by 16, it's 16. All right, so that's why that is wrong. Multiply by 16 number of metatiles. So instead of, okay, so we didn't do enough multiplications here. So 2, 4, 8, 16, and then we store it. All right. Where's the old debugger at? There you are. Okay. Run. Hit that. Okay. So now the question is, where does it think sprite mem FA3D? Where is our memory viewer? FA3D. Sprite FA3D. It still looks wrong. Let's take a look for a second here at the level object data, level object count, level 1 OBJ, which is FB1D. FB1D. So that's the beginning of our level. I think I said something about 13 bytes here. We have our level object count, which is 5, which is good. And then we have, let's see, we have that. We have our scroll counter. And then after that, we loaded that into sprite mem so that we could reference it there for the palettes with the Y. So we have our palette loop, which will give us our palette information. Is that the first part of this? No, there's also the row count. So the row count begins at the beginning of the map. So we're looking for 64. But that may or may not be it. Max rows, let's just confirm. So Y was 0, sprite mem was F4CF. F4 F4CF. No, that's F3. F4CF, which is that. So that's our max rows. And then this should be our F4D0. I believe that should be our lookup. It's either that or right after that, and then we go right into this is the tile memory, the repeating ones, which is I think what we were indexing into for the, excuse me, what we were indexing into for the offset lookup, which was wrong. I don't know why that would have been affected, but we'll figure that out in a second here. So now we're loading our palette. And we can, believe we should be able to watch this happen. Yep. Okay, cool. So that was the palette. And then we have our sprite palette. And that's all looking normal. So that's good. And then let's see, sprite mem y, load a sprite mem y. This is lookup 0 through 4. Metatile lookup. Oh, okay. We're storing it into. Right, I forgot. We're transferring that over to memory. So that's at 64. So now we're transferring our lookup table for our metatiles. Good, and then that makes sense because 3 was the value that we got for our metatile for water, but it was showing up as 1 in the map data. So that's also looking normal. The question is, why is this doing that 13? Wait, is it 13? Why is it doing that 14 times? Was it always doing that 14 times? It was. Okay. Lookup loop. This is lookup 0 through 4. Store that, increment y, increment x, compare y. Oh, we're comparing it to the, okay, yes, we're comparing it to the end of the area that we're looking at. That's right, okay. So that's fine. We have our max rows. We're getting all of this stuff set up. Just want to make sure that where we're starting in the ROM looks good, and then we can validate some of the other stuff like this math here. So sprite mem is at F4D0. Add ROM address to temp in order to seek into the map accordingly. Okay, so actually we do need to look at this a little bit better. Take the max rows, subtract by 14, and then multiply by the number of metatiles to get to the top. Take back, multiply, okay. Multiply by 16, sorry, subtract 14, multiply by 16, right, which is the number of metatiles. I should really make that even clearer. Number of metatiles in row. Okay, and then So what was the value? Let's back up here a second. I realize we're kind of like trudging through some of this, but that is going to be the necessity here as we make these changes. All right, so sprite mem y. Okay, so that's good. So we took the max rows, which was 64. We subtracted E from it. And then we're doing a shift and then a roll. And temp2 has a value of 0. So now it should have still a value of 0. Let's do this also. So what should the value be? So if it's 100, we're minusing 14. Then we're multiplying by 16. It should be 1,376. So then we're going to shift again, and this time the carry is set, so we rotate on a bit onto temp2, do another shift, carry is clear, so this is going to get shifted and it's going to be 2, another shift, carry is set, so now we're going to get 5, and we're storing into temp, so 560 hex. Okay, that's what we've got. So that's good. So now we get the sprite mem F4D0. This is going to be the same problem as earlier. So F4D0. So that's the location of what? The lookup. Well, it shouldn't meet that F4D0 sprite mem. So it's going to add 60 to that. Clear carry, and then it carried. No, okay, that actually did what it was supposed to. So now sprite mem is F530, which is over here. That's not far enough. Oh, right, because, okay, we didn't do this part yet. So then load a temp2, clear, add sprite mem +1. So we get FA. So FA30 brings us where? FA30 brings us here. And that looks close. So this actually matches up to the number of metatiles across, doesn't it? If we have 16, didn't I do this before? If we have 256 pixels divided by 16, we get 16 metatiles. So this is the number of metatiles across. But what's odd is that that doesn't seem to actually match. Why is that? Did I mess up the map? No, it's 16 across. So the whole screen across is 256, so that's fine. Is it just offset by a few bytes here so it doesn't actually line up 100%? It looks like that might be the case. All right, but that aside, sprite mem is FA30. FA30, I mean, that looks like it's close. And then we offset again. by the initial. Okay, and that's right, because we hadn't done that before, and I said it looked like we were starting from the offset, and that's what we were doing. So we add, and then we store it, and then we didn't carry, so we're going to skip there. So y is 0, and now we're getting our name table stuff ready to go. So we're in theory at the right location now. We've loaded the map data in. We've got the address where we want to start loading tiles, and so now we want to load the tiles into memory. So this is all initialization stuff. Take the X and divide by 2 to get our offset into the map. Did I misinterpret that? Take the X and divide it by 4. Divide by 4 to get our offset into the map. No, because that would be, we want to know how many tiles in, or sorry, how many metatiles in to the map we are. And then, so we shift that right, and then we store it, and then we load the Y. Well, this still says multiply by 8 row width. That's not right. So now the row width is 16. So let's see. We divide by 2, and then we want to 2, 4, 8, 16. All right, let's rebuild that. I know this is kind of just plotting through it, but again, it's easier to see it than to try and guess what it's doing. That's why you have a debugger. All right, so that's a stale breakpoint. Take Y, divide by 2, and then multiply by 16, and we're going to get 0, but that's fine. 2, 4, 8, 16. So clear the carry. Add the row offset 0, and then we get tile 1, and then we look that up in metatile lookup, and that gives us 3, and that is, if we go into our metatiles, yeah, so here's metatile 1, here's metatile 2, here's metatile 3. So that's right. So we have that. Multiply by 2 to find the subtile in metatile Y. So why is that shifting now by 16? That's shifting by 16 because we had 4x4 tiles before. So now that needs to shift, instead of by 16, that needs to be shifting by 4 because we don't have nearly as many metatiles, or nearly as many tiles in the metatile, right? We've cut that in half. So, or we've cut it in quarter, I should say. All right. So let's reload that. So that's that, and then we're going to, what breakpoint is this? Because the breakpoint's got stale. All right, so that is good. Wait, that breakpoint is still good. We have this multiply, so let's put a comment here, so if we have to change anything or look back at this, we remember why. Multiply by number of tiles in metatile. 2 by 2 equals 4. Total tiles. Alright, so we're just going to jump forward to that part. So we do our multiply by 4. We're clearing, and we're going to add transfer A to Y, and then that gives us our value of the metatile, and we'll look that up, and it's 3. Wait. Take Y divided by 2, get the actual metatile value. Is this the same thing? 2, 4, 8, 16. So we're multiplying by 16 again. Should be all right. So all right, so let's restart that again. I should have commented this a little bit better previously, but I didn't think we'd be coming back and changing this. And it was kind of like, once I got it working, I didn't really want to have to come back and change it unless we had a really good reason for it. All right, so let's see. So that offset is going to be the offset into the overall tiles, I believe. That still seems like too many. Multiply by 2 to find the subtile in the Y. And then we're loading the value. Metatiles, and then we're just putting that in, and if we look at the PPU, that's a blank tile. Interesting. Let's go to the name table here for a second. So that obviously changed, but so something is wrong with the way that I'm understanding the logic for loading the name table. Let's go back to just looking at the code for a second. So that's our offset into the map, and then this we were trying to figure out what the Y, how much Y offsets us into the map. And yeah, so we divide by 2, and then we get the number of metatile multiplied by the number of. Oh, wait a minute. This is the wrong comment for the wrong place. Oh crap, yeah, so this is where we want to multiply by 16, 2, 4, 8, 16. This is multiply by 16 to offset the number of metatiles that Y spans or strides. Right, so for each y value of the original map, we cover 16 metatiles across. All right, so then we take the row offset, which we had calculated previously, and added it so that we get the actual offset, not just the beginning of the row. We put that into y, we get the normalized metatile value by taking the value from the map and then looking it up in the metatile lookup. And that's good. And then from there, we want to multiply it by the size of the metatile, because that's our offset into the metatile data, the actual raw metatile data, which, yeah, that's fine. So we store that, and then we load mtile y, which is our metatile y value, multiply by 2 to find the subtile in the metatile y, clear carry, add carry. Which there is no offset in the beginning, but then afterwards there will be one offset. Okay. And then we store that into temp, and then we add in the row offset, which is, that's fine. And we add that in, and we transfer that back over, and then we finally load A with the tile value from the PPU, and then we store that. And then we end the values of mtile x. And if we hit, this is 32 for tile x, that's fine. Tile y, that's fine. Okay, so maybe that was what I needed to fix. Let's go back, and again, I don't think that it will suddenly start loading, but let's see if we got any closer here. So, do we have any values in here that aren't 0? We do for this, but not for this. Why? So we traverse this. Let's take a look at metatiles. I wonder if that data is wrong because of the size change, and we have extra values in there. It's possible I didn't account for that properly. So metatiles was what we were loading. That information that actually holds the raw location of the tile itself. So metatiles FBA9 FBA9 2, 3, 4. Yeah, that's too many. That's too many already. So that must be the problem, or one of the problems. Where is it writing out? What file is that from? Metatiles.bin. So it's writing out too much there. So let's see. Aha, this is okay. So it's writing 16, but really what it should be writing is max metatile max dimension, which is 32 right, before, which would have given you, so it should be, in this case, I want to divide by 8. because that's the pixels. That gives us 2. And then I want to calculate this based on the actual used value, not based on hard-coded value like I have here. Well, what we can do is metatile stride. That's just this squared. And then we just put it this way, metatile stride. So that will now become 4 instead of 16 like it was. Oh, because it's not constant. Just make it a constant up there. Constant. And then we'll rename this to metatile metatile stride, like that. So, okay, so the export was wrong in the way it was doing that. So that's good. And then let's go back to the memory for a second. So the initial thing here is wrong, and then we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. That all looks like it might be okay. How is it writing this out? Size of character. No, this is wrong too. This should be metatile stride. Okay. So that's that. And then are we writing it out as 16 anywhere else? That looks okay. Okay, here, this is also wrong. This is the asset. Oh, but that's for the filler character stuff. Right file. Yeah, okay, that's 255. Yeah, that's fine. Okay. So let's re-export this now. Unable to start. Why? Because I have that one open still. Okay. So hopefully what we should find now is that the data in the map doesn't have that big 16-byte 0 area any longer, because it's no longer correct. And instead, what we should find is that it will have something that looks a little bit more. It should have 4 bytes of 0 and then the same sort of data we were seeing, you know, starting with 59. And that offset of 59 is because we have the title screen loaded in, and it's all stuff that's kind of hard-coded that will eventually go away, or maybe not. I don't know, actually. I assume it will go away, but maybe if it's not broken, we just leave it alone. I don't know. All right, so where is metatiles? This. I want to see what that looks like. So X is C, and we're going to load A, and it's got a value of 61, and that looks way more reasonable now. So if we now jump to this, all right, now we've got a map loaded. That's what I'm talking about. Now the attributes are going to be mostly wrong. And of course loading the additional map data is wrong, but okay, cool. So that's our first step, right? We got the initial map load going. and it looks reasonable now, more or less. We know there's some problems with the attributes, but the tiles look correct. Great. So now we got to fix the attributes. So let's fix that, and then I think we'll wrap it for tonight, because what are we on, 2 hours? Yeah. All right, so now we've got to load the attributes. So, of course, the attributes are a pain. They're all based on the idea that we were using 32 by 32 to make this simpler, because I could just load 1 byte in at a time. But that's no longer the case. Oh man, okay. So the tile data, I believe, corresponds to the palette offset just naturally. So tile 1 has palette 1, tile 2 has palette 2, tile 3 has palette 3, and tile 4 has palette 4, which is not actually in use by anything. So what we were doing before is we were just taking the tile and we were shoving it into, let's see, we store it into temp, we subtract 1, we load it, we compare it to FF. Yeah, we were doing that in case it was tile 0, which just stays with 0. And now we have the fun time of dealing with the bytes related to our attributes. So let's think about how we could do, what's the easiest way to do this? So each metatile corresponds to one corner of, let's, I'm going to draw this because I need to visualize this here. So each, where's my pointer? Because we switched to 16 by 16, each attribute corresponds to this grid, right? So if we look at the grid, this is a 16, this is one metatile of 16 pixels by 16 pixels, that's one. All of these, right, are individual metatiles. So what we're going to be doing is we're going to be traversing the map, but only traversing half the attribute table. I'm wondering if it makes more sense now, instead of just loading it into, we are loading it into the attribute buffer, and then what we're ramming it into yeah, we are. Okay, so we're populating the buffer and then we're ramming the attribute buffer into memory afterwards. Okay, so that makes it a little bit easier. I thought we were, I guess maybe initially we were just doing it all at once. So, and then the whole other thing is that these are the most significant bits, right? And then these are the least significant bits, if I'm remembering that right. It's one of those things where I was glad that it was over, and I'm not sorry we made the decision, but it's definitely not my favorite thing to be messing with. Yeah, so the lower corners are the most significant bytes. So as we traverse the row, what is this? That's 64. We're just literally counting through them. We don't care about the where we are in the rows or columns. We're going to have to go back and update the bytes. Can we do this as some sort of just like kind of running buffer that we... No. That won't work. Ah, man, I don't want to change this, but I don't see any other option for populating this in a reasonable way. What I'm thinking is that we'll change this to traverse. We'll change this to traverse across X and Y, and then offset. Do we have enough precision to do that? It's 16 by, what is the, if we have 240 divided by 16, it's 15 rows, so 15 times 16. We have just enough to put that in. So we can loop through the X, loop through the Y, and then the Y value dictates what part of the if Y is even, it's going to go into, is that even right? Yeah, I guess it is, because it doesn't matter where we are on the map, it's what we've loaded onto the screen. So the Y value is even, it will, oh no, but it's the Y metatile value. The Y metatile value yeah. So the Y metatile value is even, it goes into the lower nibble, and if the Y value is odd, it goes into the upper nibble. And we just alternate between the bits. Oh, we just shift it. We alternate between if we shift it or not. Let me see here. So X and Y were both 0. The only thing is that I think I have a variable for the attribute buffer index. I do, attribute index. So we're going to use that here. We can just store X into attribute index. And we're going to use that for our counter into the attribute buffer. So what we're going to start doing now is we're going to start counting our X. And so let's see. And then do we have to add Y? How are we going to do this? I want to offset by that. No, that's not. Well, another way to do it, because it's just kind of a repeating pattern, is we could have, as we increment Y, every time we reach a boundary where we've traversed to the next row, we switch what part we're storing in, and we alternate between the lower nibble, or the lower part of the nibble, and the upper part of the nibble. That seems like that might actually work better. Okay, so we load that. Well, we need to know. We need to know how we're doing this. So we have attribute mode and attribute index, which we're not using for anything. We have temp also. Well, we're using that to store off the value that we're working with. All right, so let's do this. Let's say if attribute mode is equal to 0, we're storing in the least significant nibble, and if it's 1, we're storing in the most significant nibble, and we can just keep incrementing that every time we hit a border, and it by 0, and it by 1, so that it just keeps alternating. The more tricky part is which part of the nibble we're in. Well, it's not even that tricky. We're just doing essentially the same thing of alternating back and forth, right? Attribute index equals 0, we're storing in the least significant part of the nibble. Starting to fade here, part of the nibble, and if 1 were in the significant part of the nibble. So we're starting at the top left, which is the lowest part of the byte. So we're going to load it. And we're going to store it into temp. We're going to do this compare. All right, so we've got the value now. And then what we want to do is we want to determine where we're going to store this, or how we're going to store, what value we're going to store at this point through our process of shifting and ORing and stuff like that. So the value that we've loaded here is the value that we want for the palette index of which of the 4 palettes we're using. And then we have to say, okay, so load A and then branch if not equal, meaning it's not 0 to we'll just do this here. Okay, and if it is 0, or no, actually I want it the other way around. If it's branch if equal, because we don't need to do any shifting. If it's not equal, that means we've got the value, a non-zero value in there, and so then we want to shift it left 4 times. Enter mode is equal to 1. Shift into higher nibble. Okay. So then once we have that, we say, okay, load attribute index. And same thing, we're going to branch if equal to here, because if it's 1, we have to shift it 2 more times. Oh, except store a temp. Then we want to shift it 2 more times. Branch if equal here, so load a temp, and then store a. Actually, we can just do this twice, right? And then we're going to load a with the value of temp, whatever it is, and we don't need to do this. What we need to do is we want to, actually no, we don't want to do that. What we want to do is we want to load the attribute index, the attribute buffer first with the current value, and we want to AND it with the value, oh man, what do we want to, we have to come up with a mask for that now too. All right, so let me think about this. So if we have over here and we load that and we store that into temp2, that's going to give us FF. And then depending on what we do here, oh, wait a minute. That's not going to work either. That would have to be this. Okay, so what I'm doing is, I think this will work. We're going to create essentially an inverse mask. So and then we'll EOR, exclusive OR it to get the value that we want for the mask against the bit. Except that won't work for the partial updates of just the in. Damn it. Okay, no, that won't work. So we have our value. Get rid of this. We shifted it. We shifted it some more if we need to. So the issue is we need to mask out appropriate portion of A, and then we do OR A temp, and then store it back into attribute buffer X. So we're just setting, basically we'd just be setting the bits of whatever is in, whatever we needed to change. And then after that, we want to okay, so we want to increment attribute index, right? Because that determines which part of the nibble we're in, and we will load it, because I don't believe, yeah, we will load it, and you know, we should just do this. We'll load it, clear a carry, add carry 1, and it with 1. You know, we don't even have to do that to alternate. We could just exclusive OR it, which essentially does the same thing, but okay. Can you do exclusive OR on a memory intruder? You can load it, but it doesn't store it. Okay, so we'll just we'll do that, and then store that back into attribute index. One shift into highest portion of nibble. We may want to do that in other spots where we're just doing the AND, because now we just need to alternate the bit back and forth. All right, so this then. All right, so that's fine. Now we need to check Y to see if it is a factor of 16, which we can do using AND, like we've done with some other things. If we get 0, then we know we've hit a multiple of 16, I should say. So we'll get, if we're at 16 and we AND, if we're at 16 and we AND 16, we'll get, sorry, 16 and we AND 15. Why isn't that doing it? Does that only work in programmatic mode? If we get 16 and we AND 15, we get 0 for a 32, and we AND 15, we get 0 again. So every time we get 0, by doing that, we will transfer Y to A, and it with 15. Branch not equal to this here. If we got 0, it's because we hit the end of a metatile row. Increment, or flip the bit, I should say. Flip the bit on attribute mode. So actually, you know what? we don't even need the mask for the initial load because attribute buffer should be totally 0. So we can, this will be fine for the initial load. Flip the bit on, okay, so load A, attribute mode, exclusive war 1, store A attribute mode, so we'll just keep flipping back and forth. Let's see if this was, we've already stored that, so we need to do that. Now we increment the X, and we compare it, and then, let's see. Let's see if this is even close, or if it's a totally bogus way of doing this. We'll see in a moment. Let's go to the part where we handle all of this. Now that the tiles are loading, so all right, so if we go to the PPU, we should see, all right, we've got our name table populated correctly with the values that we expect, so that's good. Now we need to mess with the attributes. So we load A, that's the value, we store it, we decrement it, we decrement temp, load it, and it's not FF, so we're not resetting it. So attribute mode should be 0, it is. Okay, attribute index should be 0 also, it is. So we're just storing this in the, or did I reverse that? We're storing it in the lowest nibble of the lowest 2 bits of the lowest nibble. So that's fine. Okay, good. Off to a good start at least. All right, so then temp has the value that we want, which is 0 anyway. Or store it and back into attribute buffer, and then attribute index gets flipped over to 1, increment Y, transfer Y to A, and it's not equal, so we're not switching attribute mode. Increment X, compare, we're not done yet, so load A for the next one. So now we're not switching to the most significant nibble, but we are going to be shifting this by 2. So temp should now, well, it has a value of 0, so that's okay. So that's good. I want to see when we actually get to that. All right, so let's see. So Y is now 16. So now we flipped attribute mode. That's good. X is incremented. So we get our value, decrement it. All right, so attribute mode is 1. So now our value of temp is shifted 4 times. Well, let's see, so far it doesn't matter because we actually haven't had any values that are not 0. Let's just, if we run through this, what does this look like here? Or did it not update the, may not have updated. So we're not updating. Where's this code here? So we're done loading the tiles and we load our attribute buffer. So that, I guess what I want to see is if we ever get to a situation where temp is not, or is it even temp? Load Y, store and temp. Yeah, so I want to see, if we ever get to a situation where we're here and A has a value of 1. Oh, the enemy's kind of loaded. That was cool. So I want this to be conditional on, well, not this breakpoint, this breakpoint. Conditional on, no, not even that one. This one here, where if temp, let's see, if A is equal to 1. All right, so let's take a look at that. So that is good because that means we got a value other than 0. Attribute mode is 0, so we're not shifting it there. Attribute index is 1, so we are shifting it by 2. Temp is now 2, and then it's 4. Oh, 1, 2, 1, 2, 4, 8. So it's the first bit of the upper part of the nibble, so that's okay. So that has a value of 4. Attribute buffer has a value of 0. So if I OR that together with attribute buffer, A has a value of 4, and then I store it. Why is it reloading? That's unnecessary. That load A temp is just an extraneous load. Doesn't hurt anything, but not necessary. Okay, so then we flip the bit. Do we get it again at any point? We do. Okay, so attribute mode is 1. So we're going to shift it over 4 times. And then it's going to put it in that part of the nibble. And then attribute index is 0, so we're just going to leave it there. Attribute buffer is, the value is 0, it looks like. So we're going to OR it, and then we're going to store it. So, I mean, that looks like we're close. It's, I guess I'm not 100% clear on what I'm not doing right here. Let's see. Oh, I am though. X shouldn't be incremented every time. X should be incremented X gets incremented only when after the exclusive OR, this is 0. Branch not equal. to that. So let's fix this. Branch not equal to not row, didn't finish row. All right, so then we only increment x if we, oh, wait a minute. I'm looking in the wrong spot. Okay. It's for this. Or compare branch not equal to there. And here is where we do the increment of x. Get rid of that increment x. Only increment x after 2 updates because each byte of attribute buffer is for 2 metatiles on a single row. This is further complicated by the fact that we have to go back. All right, let's see if the first row gets updated correctly, and then I'll make a note for myself and we'll wrap up here because I'm done. And I'll explain what. Okay. All right, cool. So the first row is right. You know what? Maybe we can finish this. This is not so bad. So the first row is correct because what we have to do is we have to increment, and you can see it actually is partially correct moving down, but it's spaced out too much, right? So the reason that it's correct here is because we're just incrementing the attribute buffer once every 2 tiles. And then we go down to here, and then it's wrong. And the reason it's wrong is because we have already moved to the next set of bytes in the attribute table, which are for a totally different set of tiles. So what we actually have to do is we have to subtract from x we have to subtract from x when this is 1. Branch not equal. No, branch of equal to skip row decrement. So here we want to store attribute mode because we want to transfer x to a. We want to clear carry, no, set carry, and we want to subtract with carry 16. That's because we need to go back to repopulate the upper nibbles, and then after that we should proceed to increment as expected. I think that would be right. No, it's still wrong. All right, I mean, I know what the problem is. Not crazy about. We'll have to figure out a better way to do this, but so let's leave a note here to do. The increment of x, or the increment to the next row is not taking into account that we have to update the upper nibbles of attribute attribute buffer. On the same scribe of bytes we just updated. This means we skip rows of attribute updates currently and get that weird palette gap in the table display. Alright, so made some progress. Like I said, I knew this was going to be kind of a messy, long process, but it's not too bad. Could certainly have been worse. We may something fell. We may continue this on Thursday, depending on what happens. I may have to start the stream late compared to normal. Thinking potentially at like 10. But I will keep everybody posted on Twitter. And as always, if you'd like to reach out to me and ask more questions, you can find me on Twitter at Clairvis. I'm on Nintendo Age Zelius. The recording of this will be posted onto YouTube as soon as I'm done here. Feel free to comment and ask questions. I will begin working on Zero Pages episode 4 at some point soon, which will be starting off your project to get sort of the basic code working, like how you're supposed to write your code to initialize your memory and what you're supposed to do for turning off the decimal mode and stuff like that. In addition to potentially doing some shorter segments on assembly instructions. People seem to like the assembly language episode and got some value out of that, so I want to build on that and do like a 3.1 and 3.2 with certain instructions and certain things that are maybe a little bit tricky about assembly, the various assembly instructions. Anyway, thanks for those of you who watched, and have a great night, and I will see you Thursday.